When Viking fell silent in 1982, it seemed as if humanity had turned its back on the red planet. For years, Mars was little more than a distant dream once again. But then a new generation of engineers began a remarkable comeback. Smaller spacecraft, smaller robots, flying helicopters, oxygen produced on another world. And today, for the first time in history, we are seriously talking about sending humans to Mars. This is the story of how humanity returned to the red planet and why our greatest adventure may still lie ahead. After Viking, Mars exploration nearly stopped. The Soviet Union launched Phobos 1 and Phobos 2 in 1988. Phobos 1 was lost on the way. Phobos 2 reached Mars and returned useful data, but communication failed shortly before its planned encounter with Phobos. Then NASA lost Mars Observer in 1993, just days before it was supposed to enter orbit. And Russia's enormous Mars 96 mission never even escaped Earth. Mars had gained a frightening reputation. Some engineers jokingly spoke about a great galactic goal that 8 spacecraft trying to reach the planet. Then NASA changed its approach. Instead of another gigantic Viking-style mission, it would go smaller, faster and cheaper. On July 4, 1997, Mars Pathfinder entered the Martian atmosphere. After parachute deployment, enormous airbags inflated around the lander. Retro rockets fired, the spacecraft was released. Then it bounced, again and again. When the lander finally stopped, its petals opened. And from inside emerged a tiny rover named Sojourner. About the size of a microwave oven, Sojourner became the first wheeled vehicle to explore Mars. Pathfinder cost dramatically less than Viking and became a global media sensation. Most importantly, it proved that mobile exploration on Mars was possible. The road to Mars was open again, but Mars quickly reminded NASA how unforgiving it could be. In 1999, NASA lost the Mars Climate Orbiter because one team used imperial units while another system expected metric units. The navigation error sent the spacecraft far too close to Mars. Only a few months later, Mars Polar Lander disappeared during descent. Investigators concluded that it may have shut down its engines while still above the surface. In 1 year, NASA had lost 2 Mars missions. The failures exposed weaknesses in testing, communication and management. NASA reorganized its Mars program and strengthened technical oversight. And the next generation of missions began to transform our understanding of the planet. Mars Global Surveyor mapped Mars in extraordinary detail. Mars Odyssey discovered large amounts of hydrogen below the surface, strong evidence of widespread water ice, and became an important communications relay for later missions. Mars exploration was becoming a network. Orbiters mapped landing sites, monitored weather, and relayed data from spacecraft on the surface. Then in January 2004, NASA landed 2 identical rovers on opposite sides of Mars, Spirit and Opportunity. They were designed to survive for only 90 Martian days. Spirit worked for more than 6 years, Opportunity for almost 15. And Opportunity traveled more than 45 kilometers, the first marathon distance on another world. Their mission was to search for geological evidence of past water. And they found it. The rocks showed that ancient Mars had once been much wetter than the frozen desert we see today. Europe also joined the Modern Mars campaign. ESA's Mars Express entered orbit in 2003 and became a major scientific success. Its British-built lander Beagle 2, however, disappeared. For years, nobody knew what had happened. Then images taken from orbit suggested that Beagle 2 had actually reached the surface, but some of its solar panels had failed to deploy, blocking its communications antenna. It had come incredibly close. In 2008, NASA's Phoenix lander touched down near the Martian North Pole. Its robotic arm dug into the soil and exposed water ice directly beneath the surface. Mars was no longer simply a dry planet. Water, frozen today but abundant in its past, had become one of the central themes of Mars exploration. Then NASA decided to go bigger. Curiosity had a mass of around 900 kilograms. It was too heavy for the airbag system used by Pathfinder, Spirit and Opportunity. So engineers developed one of the boldest landing systems in spaceflight history, the Sky Crane. After atmospheric entry and parachute deployment, a rocket-powered descent stage slowed above the surface. Instead of landing itself, it lowered Curiosity on cables. The rover touched the ground, the cables were cut, and the descent stage flew away. It sounded almost absurd, but on August 6, 2012, it worked perfectly. Curiosity landed in Gale Crater. Its mission was not to search directly for life. It asked a different question. Could ancient Mars have supported microbial life? The answer was yes. Curiosity found evidence of ancient rivers and lakes, clay minerals, organic molecules, and sedimentary rocks formed in a habitable environment. Mars had once possessed many of the ingredients required for life. NASA used an improved sky crane for Perseverance. On February 18, 2021, the rover entered the atmosphere at nearly 20,000 km per hour. 7 minutes later, it was safely on Mars. Its destination was Jezero Crater, an ancient river delta and one of the most scientifically exciting landing sites ever attempted. Perseverance used terrain-relative navigation to photograph the ground, identify hazards and select a safe landing area autonomously. And for the first time, cameras recorded major parts of a Mars landing. We could actually watch the parachute, the falling heat shield, the surface approaching and the rover hanging beneath the sky crane. Perseverance is searching for evidence of ancient microbial life and collecting carefully selected rock samples in sealed tubes for a possible future return to Earth. But it also carried something completely new, a tiny helicopter named Ingenuity. Ingenuity was designed for only 5 test flights. On April 19, 2021, it achieved the first powered controlled flight on another planet. Flying on Mars is extremely difficult because the atmosphere is less than 1% as dense as Earth's near sea level. Yet, Ingenuity eventually completed 72 flights. Just as Sojourner opened the age of Martian rovers, Ingenuity may have opened the age of aviation on other worlds. So why did NASA eventually become so successful at Mars? Not because Mars became easy, it didn't. NASA succeeded because every mission built on the one before it. Pathfinder demonstrated a cheaper landing system. Spirit and Opportunity proved rovers could survive for years. Orbiters created detailed maps and communications network. Phoenix confirmed accessible ice. Curiosity proved the sky crane, and Perseverance added autonomous navigation. NASA also learned from failures. Mars punished mistakes, but those mistakes made later missions stronger. Until now, Mars has been inhabited entirely by robots. Orbiters, landers, rovers, and one small helicopter. But those robots are also preparing the way for something much bigger: humans. Future explorers will need to understand radiation, dust, weather, landing sites, and, perhaps most importantly, local resources. A human Mars mission cannot simply carry everything from Earth. Water ice could provide drinking water and oxygen. And because Mars's atmosphere is mostly carbon dioxide, future systems could potentially produce methane and oxygen for rocket fuel. Perseverance has already demonstrated part of this idea. Its MOXIE experiment successfully produced oxygen from the Martian atmosphere. In other words, for the first time, humanity has demonstrated the production of a useful resource on another planet. And no modern individual has pushed the idea of settling Mars more aggressively than Elon Musk. SpaceX was funded with the long-term goal of making humanity multi-planetary. The vehicle designed to make that possible is Starship. Starship is intended to be fully reusable, carry enormous amounts of cargo, and be refueled in space. And it uses methane and liquid oxygen, propellants that could theoretically be produced on Mars. The basic idea is simple. Launch Starship into Earth orbit, refuel it using tanker starships. Depart during an Earth-Mars transfer window, which occurs roughly every 26 months. Travel for several months, then enter the Martian atmosphere and land vertically. But the engineering challenge is enormous. Perseverance weighed about 1 ton. A cargo starship could be tens of times heavier. Mars's atmosphere is too thin to make braking easy, but thick enough to create enormous heat during re-entry. Before Starship can carry people to Mars, SpaceX must demonstrate reliable re-entry, rapid reusability, orbital refueling, long-duration flights, and a safe delivery of large payloads beyond Earth. Musk has also discussed sending Tesla Optimus robots to Mars before humans. The idea is obvious. Robots could inspect landing sites, deploy equipment, move cargo, prepare habitats and perhaps begin producing resources before a crew arrives. But this remains a future concept, not a demonstrated Mars program. Whether the first construction machines are humanoid robots, autonomous excavators or something completely different, robots will almost certainly prepare Mars before humans arrive. And those humans will need protection. Mars has almost no global magnetic field and only a thin atmosphere. Radiation is a serious problem. Early settlers may therefore live in heavily shielded structures beneath Martian soil or perhaps inside natural lava tubes. The first Mars base may look less like a science fiction glass city and more like a combination of an Antarctic research station, a submarine and an underground mining facility. And the timeline remains uncertain. SpaceX's Mars schedule has changed repeatedly, and Starship still has major milestones to prove much closer to Earth. So we should separate the vision from the schedule. The schedule may change, the vision has not. A self-sustaining human civilization beyond Earth. And that brings us back to Viking. 50 years ago, Viking 1 gave humanity the first clear view from the Martian surface. Rocks, dust, an empty horizon. But that empty landscape did not end our fascination. It made the mystery even greater. Because every generation has asked a different question. Are there canals on Mars? Is the planet dead? Did water once flow there? Could life have existed there? Could it still survive underground? And now, could human beings one day live there? Today, Perseverance is exploring an ancient river delta. Robots have flown through the Martian sky. We have produced oxygen from its atmosphere. And Starship represents one possible bridge toward a human future on the red planet. The next great race may not simply be about reaching Mars. It may be about building something that can survive there. And perhaps one day transforming humanity from a civilization living on one planet into a civilization living on two. I hope you enjoyed the video and I will see you soon in the next one. Ciao.